Hi, this is Michael. I'd like to share with you how to solve Homework 5 Easy using MATLAB. The data we're using is from Hart and Risley's 1995 study, originally stored in a .save file. Those files are for SPSS, so I have to convert it to an Excel sheet, or in this case, a .csv file. So let's first load our data using the read table command, and we'll store it in a variable ds. I'll use a semicolon to suppress the output. As we can see, now our data is ready to be used in our workspace, saved in the variable ds as a 42 by 12 matrix. To make our lives a little easier, let's store our variables of interest into different items. Let's start with guidance style, which we'll store in the variable style. We'll tell MATLAB that we're taking from the DS matrix, and the column we want is guide style. Let's do the same thing for vocabulary use. We'll call this one vocab. Before we can run the correlation tests we want, we need to check for normality. In the previous video, we saw that MATLAB has commands to check skewness and kurtosis, but unlike SPSS, it doesn't automatically give us the standard error for both. But there are many different formulas to calculate these. So MATLAB is great because we can create our own function. I won't go too much into it. But essentially, here's a formula, and it's based on sample size. We can't just use standard error to test for normality. We have to use it to divide the skewness and kurtosis values. So I made another function to do just that. Interestingly, SPSS actually calculates excess kurtosis, which factors in a correlation value of -3, which I counted for here. So let's run this function. We have to use brackets to call for an array, since the function is going to output the standard error for both skewness and kurtosis. Let's call these variables r_skew and r_kurt. Let's start with style. And here are our two ratios. We can see both ratios fall within the boundaries of -2 and 2. So therefore, our style is normally distributed. Let's do the same thing for vocab use. Let's call this rskew2 and our kurt2. Similarly, this variable is also normally distributed. Since both variables have normal distributions, we can now run our correlation test. We'll be using a Pearson's correlation test, which is automatically two-tailed in MATLAB. The function outputs two variables, so we'll make an array for our command. Since we want both our correlation coefficient and the p-value. The command for this is corrcoef, and we want to use style and vocab. And here we see our correlation coefficient and our p-value. These values on the diagonal we can ignore, but we can see based on our correlation coefficient that we have a statistically significant relationship that is both strong and positive. We can also see that our p-value seems to be 0, which is impossible. But if we go here to p, we can see that it is very, very, very small, but not 0. The next part of the assignment is to graph our data. This is easy to do in MATLAB. All we have to do is type scatter and put our two variables in. I'll put vocab on the x-axis and style on the y. And here we have our graph. A benefit to MATLAB is that it's easy to customize graphs. So let's close this. We'll use the up arrow, which we can do to recall commands, recently used commands. And let's add a star for the plot points and R for the color. And now our graph is a little easier. The scatter plot now has a little bit better visibility. So to summarize, we ran a two-tailed Pearson's correlation test and found a statistically significant relationship that was both strong and positive. Our R value was around 0.67, and our p-value was near 0. And of course our n was 42. Though we did find a correlation, we cannot conclude that there is causation. It's tempting to say that we can test or control for other variables, but even so, that still cannot establish causation. I hope this provided a little more insight into the capabilities of MATLAB and how to test for correlation. If you have any questions, feel free to reach out to me on my student email, and thank you for watching.